Irrigation Engineering in Unit 4, Canal Irrigation. In inundation irrigation, the canals are excavated from the banks of the inundation river. The bed level of the canal is such that the water can flow in rainy season only when the water level in the river rises above the canal bed. The construction of hydraulic structures is not necessary in this system. There is no head regulator to control the flow of water through the canal. In this system, water is not available throughout the year. The network of canals, this main canal, branch canal, and distributary canal, is constructed from the source to agricultural lands in the perennial irrigation. Here, the head regulators were constructed to control flow of water through canal. Canal is defined as an artificial channel constructed on the ground to carry water from a river or another canal or a reservoir to the field. Types of canal. Canals are classified based on source of supply. Two types, one permanent canal and inundation canal. Permanent canal continuous water sources of water supply, also called as perennial canals. Inundation canal draw its supplies from a river only during the high stages of the river. Based on function, canal classified in irrigation canal, navigation canal, power canal, and feeder canal. Irrigation canal carries water from its source to agricultural fields. Navigation canal used for transport of goods. The canal which is constructed for the purpose of inland navigation is known as navigation canal. This type of canal is also utilized for irrigation. For example, Ganga Brahmaputra navigation cum irrigation canal and power canal. The canal which is constructed to supply water with very high force to the hydroelectric power station for the purpose of moving turbine to generate electric power is known as the power canal or hydel canal. Power canal is also called as hydel canal. For example, Nangal hydel canal and then feeder canal. The canal which is constructed to feed another canal or river for the purpose of irrigation or navigation is known as feeder canal. Feeder canal example Paraka Barrage feeder canal. Types of canal based on alignment. Watershed canal or ridge canal and contour canal or side slope canal. Watershed canal or ridge canal. The canal which is aligned approximately parallel to the contour line is known as contour canal. This can irrigate the areas on the side only. This canal may cross natural drainage and hence cross drainage works are necessary. The dividing ridge line between the catchment areas of two streets is called as watershed or ridge canal. Thus, between two major streams, there is the main watershed which divides the drainage area of the two streams. The canal which is aligned along any natural watershed is called watershed canal or a ridge canal. Aligning a canal on the ridge ensures gravity irrigation on both sides of the canal. Since the drainage flows away from the ridge, no drainage can cross a canal align the ridge. Thus, the canal aligned on the ridge watershed the cost of construction of the cross drainage work. Watershed canal, cross section of the watershed canal or ridge canal. Next, contour canal. The canal which align approximately parallel to the contour line is known as contour canal. This canal can irrigate the areas on one side only. This canal may cross natural drainage and hence cross drainage works are necessary. Watershed canal along the ridge line are not found economical in hill areas. In hills, the river flows in the valley well below the watershed. In fact, the ridge line may be hundreds of meters above the river. It therefore becomes virtually impossible to take the canal on top of such a higher ridge line. In such conditions, contour canals are usually constructed. A contour canal irrigates only on one side because the area on the other side is higher. This is the cross section of contour canal. Next, side slope canal. The canal which is aligned approximately right angles to the contour line is known as inside slope canal. It can irrigate the area on one side only. Again, it does not cross any natural drainage and the cross drainage works are not necessary. A side slope canal is that which is aligned at right angles to the contours, that is, along the side slopes. Since such a canal runs parallel to the natural drainage flow, it usually does not intersect drainage channels, thus avoiding the construction of cross drainage structures. It is a canal which is aligned roughly at right angle to contours of the country, but not on watershed or valley. This is the cross section of side slope canal. Types of canals based on discharge, it classified into main canal, branch canal, distributary canal. Distributary canal is also divided into major distributary and minor distributary, and finally watercourse or field channels. Main canal. Main, the large canal which is taken directly from the diversion network or form storage reservoir to supply water to the network of other small canals is known as main canal. The irrigation water is not directly supplied to the field from the main canal. The water is taken to field through the branch canal, distributary canal, and field canal. So, the main canal is the backbone of the canal system. Main canal takes off directly from the upstream side of river headworks or dam. Usually, no direct cultivation is proposed in main canal. This is the main canal. Branch canal. The branch canals are taken from either side of the main canal at suitable points so that the whole command area can be covered by the network. The discharge capacity of the branch canal is smaller than that of main canal. The discharge varies from 5 to 10 metric cube per second. All takeoffs from main canal with its discharge of 14 to 15 cubics and above are termed as branch canal, act as feeder canal for major distributaries. This is the branch canal. Next, major distributary canal. The distributary canals are taken from the branch canals to supply water different sectors. The discharge capacity of these channels varies from 0.25 to 3 metric cube. Again, these are designed as major distributary and minor distributary according to their function in total network. Major distributary canal all takeoffs from their main canal or branch canal with a discharge from 0.25 to 15 cubics are termed as major distributaries. Minor distributary, all of takes taking off from a major distributary carrying discharge less than 0.25 cubics are termed as minor distributaries. Watercourse or field channels. These channels are taken from the outlet of the distributary channels by the cultivation to supply water to their own lands. These channels are maintained by own land cultivators. Small channels which carry water from the outlets of a major or minor distributary or a branch canal to the fields to be irrigated. This is the major network of a branches of canals. The center is the main canal. Again, the main canal divided into minor distributary canal and major distributary canal. This is the branch canal. Main canal divided into branch canal. Branch canals is again divided into minor distributary and major distributaries. Next, types of canals divided into lining based on lining provided or not. That is unlined canal and lined canal. Unlined canal, bed and banks made up of natural soil, water velocities higher than 0.7 meter per second are not tolerable. High seepage and conveyance water losses. Profuse growth of aquatic weeds retards the flow. Lined canal. Lining of impervious material on its bed and banks to prevent the seepage of water. Different types of lining used. Examples concrete, brick, or burnt clay, tile, or boulder. A picture of a unlined canal. This is the unlined canal. This is the lined canal. Cross section of irrigation canal. This section is partially cutting and partially filling and aims in balancing the quantity of effort in excavation with that in filling. This is the canal cutting. This is the filling. So this is the partially balancing, cutting and filling. When the NSL is above the top of the bank, the entire canal section will have to be in cutting and it shall be called canal in cutting. Similarly, when the NSL is lower than the bed level of the canal, the entire canal section will have to be built in filling and it is called canal in filling. Components of cross section, side slope, berm, freeboard, bank, service road, back berm or counter berm, spoil bank, bar of it, side slope. The side slope should be such that they are stable depending upon the type of the soil. A comparatively steeper slope can be provided in cutting rather than in filling, as the soil in the former case shall be more stable. Berm. This is berm. Berm is the horizontal distance left at ground level between the toe of the bank and the top edge of cutting. This portion is called as berm. Purpose of berms. They give additional strength to the bank and provide protection against erosion and breaches. They protect the bank from erosion due to wave action. They provide a scope for future widening of the canal. Freeboard. The margin between FSL and bank level is known as freeboard. The amount of freeboard depends upon the discharge of the canal. This portion is known as freeboard. Bank. The primary purpose of banks into the re- retain water. This can be used as mean of communication and as inspection paths. Service road. Service roads are provided on canals for inspection purpose, simultaneously serve as being the as the means of communication in remote areas. Back berm or counter berm. Even after providing sufficient section for current embankment, the saturation gradient line may cut the downstream end of the bank. In such a case, the saturation line can be kept covered at least by 0.5 meter with the help of counter berms as shown in the figure. This is the counter berm. Spoil bank. When the earthwork in excavation exceeds earthworks in filling, the extra earth has to be disposed of economically. Economical mode of its disposal may be collecting the soil on the edge of the bank embankment itself. Borrow pit. When Earthwork in filling exceeds the earthwork in excavation. The earth has to be brought from somewhere. The pits which are dug for bringing earth are known as borrow pits. If such pits are excavated outside the channel, they are known as external borrow pits. If they are excavated somewhere within the channel, they are known as internal borrow pits. Internal borrow pits are more preferred than external one. This is the borrow pit. This is the example of balancing depth of the balancing cutting, the depth for which excavation and filling becomes or equal. This is the another example. In next class, we see losses of water in canals. Thank you.